I'm Colin Walls, and I'm here once again to talk about embedded software. Today I want to revisit a subject that I've talked about before and I'll probably talk about again in the future, and that is the use of low power. The idea being that we need to reduce the energy consumption of devices, and this is needed because of extending battery life, but also for environmental reasons. I'm looking at it from the perspective of a software engineer. In the past, power management was very much considered a hardware issue. Nowadays, it's recognised the software can have a very big influence. Now, there are a number of things that can be done in software to manage energy consumption. Broadly, they fall into three categories. I want to mention a couple of them and then go into a little more detail today about the third. The first one is Dbfs. This is a facility called Dynamic Voltage and Frequency Scaling. The idea here is very simple, that the higher the voltage and the higher the frequency that you run a CPU at, and those two things are related, but basically if you think in terms of just the frequency, the higher the frequency you run the CPU at, the more power it will consume. That's fair enough, because at high frequency you can do more work and you don't get anything for free, so it makes some kind of sense. But if you need to do less work because of the particular state the machine is in, reducing the clock frequency makes a lot of sense. If you can get the job done at a lower frequency, you will use less power. And Dbfs is a mechanism whereby the software can control the frequency of the CPU. Second topic, second possibility for reducing power is turning off unused peripheral devices. So the CPU itself will be in use essentially all the time, and so will memory in general, but all the peripherals around it may not be needed all the time, and switching them off could save substantial amounts of power. So assuming that that capability is built into the hardware, the software should apply it. The last of the three things that software can do to manage power is the one I want to spend just a few more minutes on today, and that is low power modes of the CPU. Broadly speaking, if we get away from thinking about a changing frequency and so forth, a CPU is either doing something or it's not doing something. If it's not doing something, it would seem logical that just turning it off would make sense, because that would save power. Well, actually, but that wouldn't work, because how would you wake it up again necessarily? You probably need the CPU to be in a suitable state that it can be started again. Just turning off the power may not be the best thing to do. So most modern CPUs have some low power modes built into them. The terminology is a little bit different from one device to another. But broadly speaking, we can go into a low power state in one of two ways. And in the Windows computer world, we call these Suspend and Hibernate, and they are pretty good terms really. Now, Suspend is the easy one. All you do is you shut down the entire system except for the memory. This means that when something wakes the system up again, whatever that something might be, the CPU can start running again. It may have been running at a very, very, very low frequency, it might have stopped entirely, but in any case, when it starts up again, the memory, because it's had its power retained, contains all the data and code, and you can carry on operations. So you start up again very quickly. The alternative facility is called Hibernate. Hibernate has the advantage that it saves even more power, because what happens is when you go into Hibernate state, the entire contents of memory are stored somewhere, typically in flash memory in an embedded system, and then everything is switched off, including the memory. So the battery will then last indefinitely until you come out of the Hibernate state. The downside, it takes longer to get into Hibernate and longer to get out of it again. So there's pros and cons of these different modes. And indeed, you may design a system which will automatically go into suspend mode when it makes sense, but after a certain period of time in suspend, it will decide that Hibernate will make more sense henceforth. Now, you need to be a little careful using these modes, not to basically use them too much. That sounds stupid, because if you're saving power, how can you save too much power? Well, the downside is going into these modes uses power. You have to execute some code to get yourself into the suspend state, and you have to execute quite a lot of code to copy all the data to use Hibernate. So you may use a bit more power going in and out of the modes than you save by being in the modes, so you need to be careful there. The other thing is your system will suffer with responsiveness issues if you use Hibernate too much. If the user presses a button to use a device and it takes a noticeable period of time to start up, that will cause user dissatisfaction. That responsiveness is a problem. So you need to use Hibernate sparingly and at the right times, and not in a way that will make the user unhappy with the way the device performs. So it's a very quick look at some different aspects of managing power from embedded software, and I hope it gives you a flavour for a topic that I will return to another day. So until next time, when I'll be talking about some other aspect of embedded software, I'll say bye for now.